IDA traces each ground motion's response through a series of increasing intensities. You get one curve per record, intensity on one axis, drift on the other, starting in the elastic range, moving through yielding, all the way to collapse. One thing worth clearing up: early fragility analysis also has something called an IDA fitting method that's different from this window. That method uses IDA data to fit fragility curves. This window is where the IDA curves themselves actually get built. Before you open this window, you need results already sitting there. A series of nonlinear time history runs, different ground motions, different scale factors. This window doesn't run any analysis itself. It reads what you've already run and processes it. First button to press, load extract max IDR. This goes through every ground motion, every scale factor you've run, and pulls out the maximum interstory drift ratio for each one. It fills the data table for you. Direction picks which response direction builds the curves, combined X or Z. Inspect node allows you to add node number where you need to measure interstory drift ratio. Also, it has auto option to select worst response among all nodes. If you select manual option, all available ground motions will appear under Inspect Nodes section, and you can add required node manually and then press Load button to update the data table. If something needs a manual fix, you can edit any value directly in that table. Next, press Spectral Acceleration button. This brings in each run's spectral acceleration at the structure's fundamental period. That value was saved earlier, back in time history analysis. Same as the drift data, you can edit these values directly too if needed. Collapse drift sets the threshold, 10% by default. Above that, a record counts as collapsed. And here's something worth knowing. A record also counts as collapsed if the analysis simply failed to converge. That happens independently of this threshold. Now, fractile method. You're trying to get summary curves out of a whole set of ground motions. The 16th, 50th, and 84th percentile. IM-based is the recommended option. Here's how it works. At a given drift level, you look across all your records and ask, what intensity did each one reach that drift at? Then you take percentiles of those intensities. Why does this matter? Because once a record collapses, it just stops contributing data past that point. It doesn't get stretched or guessed at, it's simply excluded from the sample beyond its own capacity. That's why this method stays reliable even near collapse. EDP-based flips it around at a given intensity. You look at what drift each record reached, simpler to picture. But it runs into trouble once records start collapsing. A collapsed record technically has infinite drift, so it gets assigned the collapsed drift value just to keep the math running. Once a large share of your set has collapsed, that 84th percentile line stops meaning much. Show individual records plots every ground motion's own raw curve. Show 16, 50, 84 fractiles plots the statistical summary lines using whichever method you just picked. Mark collapse points flags exactly where each record's curve was judged to collapse. And log IM axis switches the intensity axis to a log scale. Useful if your scale factors span a wide range, a linear axis would squash the lower intensities together and make them hard to read. Once everything's set, click Generate IDEA Curves. The curves get built, plotted, and saved all in that one click. You don't need a separate save step afterward, but if you go back and edit the data table by hand after generating, without regenerating, you do need to click Save IDEA Curves. Otherwise, those manual edits won't stick. Export PNG saves the plot. Export Excel gives you the underlying data. Every record, every scale factor, plus the fractile curves. Export PDF builds a full report methodology, the options you used, how the fractile method is defined, the curve figure, and the data table behind it.